Hi everyone. I'm going to go over question number 9.2 from the bingo problems. This problem says that an airplane propeller is rotating at 1900 RPM, or rotations or revolutions per minute. Part A wants to know the angular velocity in radians per second. So to do this, this is really simple. All we need to do is dimensional analysis to convert RPM to radians per second. And so the way we do that is we know we have 1900 RPM. And to change, so we need to change the minutes to seconds and the revolutions to radians. So we'll start with the revolutions. We know that one revolution is equal to 2 pi radians. So we want the revolutions on bottom, so those cancel. And then to do our minutes, we know that 1 minute is equal to 60 seconds. Now, when we put that into our calculator, we get about 199 radians per second. So, we'll say so there's our angular velocity. Now what we need to find for part B, it says how many seconds does it take for the propeller to turn 35 degrees. So the first thing we're going to need to do is convert the 35 degrees into radians, since the equations we're going to use, or the equation requires the angle to be in radians. And so the way we do that is similar to what we did in part A. We have 35 degrees, and we know that 360 degrees is equal to 2 pi radians. So we plug that into our calculator and we get that 35 degrees is about 0.61 radians. So we'll just put that here. So 35 degrees equals about 0.61 radians. Now we're going to need to use one of our equations, and it's that time is equal to the angle over the angular velocity. Since we're looking for time, and we found the angular velocity in the previous step, or part, and we found our angle in radians, we have everything we need. So that's going to be t equals 0.61 radians over that angular velocity we found, which is 199 radians per second. Our radians cancel, we end up with seconds, and that time ends up being equal to about 3 times 10 to the negative 3 seconds. And that makes sense, because if it's traveling, 1900 rotations per minute, 35 degrees is just a very small part of one revolution. So it's going to make sense that that time is going to be very, very small, a very short amount of time for it to go that distance. So anyway, that's it for question 9.2. I hope you enjoyed watching, and I'll see you in the next video. Thanks.